Hello and welcome to Fully Charged for an episode that I think could be my favourite. I'm out here in Berlin in a hipster coffee shop to drive something that's going to be pretty special. It's an Audi Quattro that I'm allowed to drive, although I can't actually sit in it, and it does a maximum speed of 2.2 miles an hour, and they reckon it could be the most expensive Audi ever produced. It is a car that is really out there, and when I say out there, it's properly out there. All will be revealed in a second. Okay, so we've just been dropped off by the taxi. On this side is a block of flats, a huge block of flats. Number 82 is where the taxi dropped us off, and we were like, don't think this is where Lunar Quattros are made. And then we looked to the left, and there's a big building, 82A, which is PTScientists, which sounds a little bit more realistic. So hopefully... Hello, Kate.
Welcome to Moonbase Berlin.
Hello, thank you very much.
Come on in.
Go on in, go on, come on. I'm looking forward, to seeing some technology.
We will not disappoint you, I'm
some
sure.
moon-based technology. How did this whole idea come about?
So our CEO, Robert Boehm, is also our founder, and it started about because he heard about the Google Lunar X Prize way back when, and got a group of his friends, engineers, scientists, got them together and said, is there a reason that we shouldn't go to the moon? Or try and go to the moon?
Try and go to the moon.
Yeah, and instead of them saying, Robert, you're completely crazy, they were like, not really, not what we think of, and that's how they started. And it was originally the part-time scientists, because these were all part-timers just doing it as a hobby, as a passion, until they kind of realised that A, they're onto something, and B, this is rocket science, and if you're going to go to the moon, it's kind of a full-time, overtime business. So yes, we're now the PT scientists. There's nothing part-time about us anymore.
This is not the Quattro, the Lunar Quattro, is it?
Oh, no. No, the Quattro is much smaller and much more mobile. This isn't really going to be moving anywhere. Well, obviously it's going to move between Earth and the moon, but then
that's moving a lot.
That's quite a lot, it's true. But when it settles down on the moon and delivers our 2 Audi Lunar Quattros, it will just be done. But then it has a few other things, a few other tricks up its sleeve. So firstly, we have the payload rack over here, and we're actually allowing people, businesses, universities, anybody really who wants to send payload to the moon, experiments, whatever they want to send. And these are our little payload boxes. This is a standard cube satellite size. So it's 10 centimeters by 10 by 10. In terms of satellites, you used to have like enormous satellites that are about the size of a bus. And so you and me, we could never do that because they're big, they're expensive, and they need very, very special components. But with cube satellites, you can start to use less expensive components. So some people have done this and actually used Android mobile phones as the onboard computer. And we have these 2 blue things here would actually allow you to pop the cube satellites into lunar orbit.
My word.
Which is kind of awesome.
This is technical, I love it.
You may see this Vodafone logo and think, what on earth is a mobile phone company doing on the moon? Well, what we're actually doing is setting up the first mobile LTE base station on the moon.
Right.
And again, not many customers up there, but what it will allow us to do is when we've got our Audi Lunar Quattros driving around on the moon, they can connect down to Earth and send data, but it takes a lot of energy, and they're only quite small. So we could send live video, but only when the rovers are stopped.
Right,
which isn't so exciting. But if we use LTE data, we can take the high definition video from the rover, bounce it back here to Alina, which obviously
sat here on a
isn't
crater
moving.
Somewhere.
And it can then beam it back down to Earth, and we'll have the rovers roving, and you can see the live pictures down on Earth. There are only 3 countries in the world that have ever made it to the moon. The US, Russia, and China, and it's always been government space programs. So we want to show that a private company can get to the moon. That's the first thing. Then we have the technology demonstration of using LTE connectivity on the moon. And the really exciting thing for me is that we're actually going to go back to the Apollo 17 landing site. So this is where the last footsteps on the moon have been left. And they had a car as well. They had the original lunar roving vehicle. and it's been sat there for...
Which they drove around in?
They drove around in,
yeah.
And yeah, it's been sat there for 45 years on the moon. We know it's there because a NASA orbiter has, taken pictures, but you can see it as a tiny blob.
You know it sat where it sat, but you don't know any more detail?
Nothing
So
more.
you basically want to drive up to an abandoned car on the moon. Let's not mash our words.
Yep.
This is great. Don't get me wrong, I wasn't expecting to see this. This is marvellous. But I'd like to now see the things that live inside it, the car-shaped things. The Lunar Quattro.
The Audi Lunar Quattro.
That's actually been in a film.
Yeah, it's been in the latest Alien film, Alien Covenant, and you see it rolling down the ramp.
Cool.
Yes.
That's brilliant.
Our catchphrase.
Oh, there it is.
Yeah.
Wow. And it's smaller than I thought.
Yeah, the funny thing is that people always come in and say, well, it's much smaller than I think it is, or they say it's much bigger than I think it is, but no one is coming in saying, this is exactly what I expected it to be.
It's incredible. Okay, so talk me through this thing.
So you have the four-wheel configuration. We have that can be turned independently, and each can steer independently, drive independently.
So it's like a chameleon's eyes.
Yes, exactly. We can
you can turn
we can drive like this, which would be not very good. Yeah, but we can also turn on the sport, and we can sideways driving and everything. Yeah.
Wow. Well, this is a really unusual episode for us on Fully Charged because it is a car. It's an unmanned car that's electric, using solar panels to self-charge, and obviously there's a connection with Audi. So Quattro, obviously, four-wheel drive, in-wheel, in-hub motors.
We were able to save 10 kilograms just by using 3D printed technology and make it hollow. So those beams, for example, they are hollow, which allows them to run cables through, and it's extraordinarily stiff.
10 kilos is a lot.
Yeah.
Especially when you do, I mean, it's not a very big thing anyway, and I know sending anything to the moon's got to cost quite a lot.
Yeah, so the thing is that we are selling payload capacity for 1 kilogram costs 800,000 euros. So when we are saving 1 kilogram, we can potentially sell 1 kilogram or 800,000 euros of payload. So 8 million we saved.
8 million euros, sorry.
Yeah, and we have 2 rovers, so 16 million in total.
16 million euros because you've shaved 10 kilos off each rover.
Exactly, yeah.
Wow, I mean, that's like up there with Ryanair oversized baggage. You've been working on this for how many years?
So we started by the end of 2008, and there we developed our first generation rover, which was much smaller. It was about this size, like a shoebox size.
Yeah.
And then we developed further. We learned a bit more about the moon, and in particular, the first challenge we had was the size of the solar panel. It was too small to fulfill all the tasks that we need to do on the moon, like driving and transmitting video.
Yeah.
And so eventually we ended up with this size, which is the perfect size for having a car driving on the moon.
This is what I love about it. So this hasn't got big claws on it for grabbing pieces of rock.
Yeah.
It's not collecting physical stuff. It's to transmit high quality pictures and video.
So what's really cool about this is the camera system. So we have 2 cameras on the outside, which are color cameras that can capture 3D imagery, and we can transmit that back to Earth. But the middle one is of special interest because it's a telelens.
Okay.
So it can focus on stuff very far away, and it's a black and white sensor, and it has a filter wheel in front of it. So we can switch between different wavelengths, and with that we can do some basic material analysis.
What are we dealing with here? What's this got to contend with?
So the lunar surface has a temperature of about 120 degrees Celsius when it's lit by the sun. And once the sun is gone, the temperature drops to minus 180 degrees Celsius. So that's a 300 Kelvin difference.
That's huge.
Yes.
So 120 degrees Celsius and then at minus 180.
Yes.
And for an electric vehicle, that's incredibly challenging.
So the good news is...
It's not all bad news, obviously, traveling to the moon to drive.
Yeah. Well, so the good news is we only care about the lunar day, which is like half a month. So when you're standing on the moon, you have half a month of sunlight and half a month of darkness.
Okay, right.
And so we are only dealing with the sunlit part, because obviously if we don't have sun, we can't drive.
Yeah.
And so We have 14 days of about mission operation on the surface.
Yeah.
And once the temperature drops, there's not much left than praying, because no manufacturer in the world will guarantee you anything for dropping from a temperature of 120 degrees to minus 180 degrees.
Yeah. So this car, the mission of this car is to last 1 lunar day.
Exactly.
And 1 lunar day is half a month.
Exactly, yeah.
So it will operate for half a month, and if you get anything out of it beyond that, then that's a bonus. Bonus.
Yeah.
So let's have a look around here. So the batteries live inside its spine.
So the thing is that what we call this the tunnel. The lower part is for reflecting the heat coming from the soil.
Yeah.
And the upper part is for dissipating the heat into space, right?
Yeah.
And so the coolest part in the rover is literally coolest part is the battery pack. Yeah. Because you don't want to get the batteries to 120 degrees Celsius. They barely even like 90 degrees.
Yeah. They live all inside here, or just in the top layer?
Just in the top layer. It's about 270 watt hours, so it's not huge like in a car.
Yeah.
And the electronics sits just below it.
Obviously the antenna for...
Yeah, this is for Earth communications, right? This is a Bluetooth antenna.
For Earth
nothing
communications.
Too fancy, yeah.
And these little
and
jacks.
This is the key to the rover. This is how you get...
That's the key?
Started, yeah. It's very fancy.
It's like a headphone jack. So you just put that in and then...
Yeah, but you can do quite a lot of wrong by just putting it in there. I know.
And you've got different tyres for it. You've got different wheels and tyres.
So we're always experimenting with different tyres, and those ones are the ones that make the least noise on the carpet or on the floor. Okay. And so those are the ones that we're using for presentations. For rough terrain, you obviously want to have something better, right? And those are the ones that you can see there. This is the ones that we're going to use on the moon.
They're more like a sand tyre, aren't they?
Yeah.
So you do everything in-house here?
Essentially, yeah.
Yeah.
Well, so the milling part, for example, the parts, so we are designing the parts, we are sending them out to manufacturers, and then we do the integration.
And Audi are helping to build some of these parts, are they?
Yeah, so they have a laboratory where they do 3D printing stuff, and this is a custom blend of aluminum that they made, which is very strong.
I want to know how long it's taken to build this.
So it takes about 6 weeks for assembly.
6 weeks?
Yeah, it's not long.
It doesn't seem like a very long time, and neither does the cost. I keep thinking about it. You're saying about €250,000. Yeah. Which is so cheap for aerospace terms.
Yeah, because we are ordering at those non-aerospace firms, because if you get a price tag, if you say it's for a space project, then you get like double the price. There's no reason behind it.
Absolutely. Is there a chance of me actually being able to drive this?
Sure. We can just take it downstairs to our test bed, and then we can drive around a bit.
You don't need to call anyone for clearance. You just lift it up and walk downstairs with it. Yeah. Do you really?
Yeah.
So Young, your job is you're the mechanic. You're the main mechanic in this project?
I'm the Chief Technology Officer of PTS, and my experience is mechanical engineering. I came originally from the medicine industry. I do dental stuff. So
dental?
There's drilling machines for your teeth.
Okay. So very small, powerful...
Very small, powerful, but also high technology.
So run me through some of the key challenges that you had, because in front of us here, we've got some unbelievably light suspension. This is parts of the suspension?
This is a part of a suspension.
Yeah.
This is 3D printed with aluminium silicium based powder.
To give you an idea, it's really hard to portray how light this is. I would say this is the same weight as an empty packet of, is it pommes frites?
Pommes frites, yeah.
Pommes frites, yes. It's an empty bag of crisps, that is, and that's incredibly strong.
But it's not only lightweight, so we have also the possibilities to do something like making holes, where it's impossible to make holes with other manufacturing,
with physical
machining or so on. So we can have the cables into these holes.
Yeah.
And nice for design and also for shielding the cables.
For safety, yeah.
And what we also have there is one of our wheels. Also you design it in CAD, and then you say you want to have 1 millimeter. Exactly, over the whole wheel.
Yeah.
And you can print this. Impossible to make it with machining. This is machined, and this is, I think, 100 grams heavier than this in the final version.
And what's the cost difference?
2,500 euros to 1,500 euros. So it's the same strength.
Same strength.
It's lightweight, it's cheaper to manufacture in it. Every gram we can save on the Rover, we can put, let's say, experiment on our lander or save money for the whole project. We have 2 of this Rover because of redundancy. If someone fails at one Rover, but also for the nice feature, one Rover can film the another one at driving. And our main goal is to film Apollo 17, the landing site. And it's really a nice picture. If one Rover drives to Apollo 17 and another Rover will film this scene.
Yeah, they could do selfies.
Yeah, we can take selfies and if a Rover got stuck, we can try how we can fix this problem. What can another Rover do? Yeah. To save the first one or who have a problem.
You might be able to use one to push the other out or pull, or even if you're not interested in space travel, I think it's still awesome. And if you're not interested in space travel, then why? What are you thinking? I think we should go and drive it. Great, isn't it? This looks like an 80s hotel. You come down here, you've got the toilets on the left, got a shower room on the left, and then you just walk, I don't know, 12 foot further, and then, oh look, it's a spaceship on the left as well. It's a real spaceship. It's real. And then, that's just sitting there on a crate, and then we're in this like gymkhana area where you've been playing around trying to tame robotic moon roving vehicles. This is awesome. So what is this? Is this normal soil?
This is a basalt from a volcano. One of the interesting things about it is because it has the same size distribution as what you expect on the surface of the moon below the dust.
Yeah.
And it also has sharp edges. And this is broken material.
Okay, so
which is more what you expect on the moon.
You are basically trying to replicate the surface of the moon in a warehouse in Berlin.
Yep.
This is brilliant. These are like sand tyres, like on they call them paddle tyres, so they've got a really good scooping.
Yep.
But if you were going to drive with this on a smooth road, it would be a nightmare.
Yeah, exactly. Yeah.
What are the do's and don'ts of driving the Lunar Quattro?
Well, essentially, you can drive like this, and you can go a little to the left.
Okay, so you just swipe.
You just stay where you want to go, essentially. But you can turn on the spot, which is really nice.
Its head moves really quickly.
Yeah, sure.
Just noticed that. With that antenna there, it actually looks like it does look like a robotic dog.
Yes, this is what you hear occasionally. Or turtles.
Quattro dog.
And it can go sideways, as I was explaining upstairs.
Like a crab. Wow. Does it just all self-right when you like a steering wheel on a car when you're driving? When you let go, it self-centers.
Yeah, exactly. Yeah. And this is what we would see on the moon most of the time for driving around, because, for example, now the sun is coming here.
Yeah.
And if we align the solar panel like this.
Yeah. Because the sun, say the sun's over there.
And we want to drive towards the sun, then we do it like this, and it always keeps optimally aligned.
Favouring the sun the whole time.
Yeah, exactly. So the cool thing is we designed this app actually for our small rover so that children can drive it. And I think it's children usually pick it up very quickly, whereas the older adults have quite a problem usually.
I like to think I'm more child than older robot.
Yeah.
Adult. That's a Freudian slip.
Mr. Dobrindt, our minister for highways, he was very good at picking it up as well.
Was he?
Yeah, he was. He said he had a remote control car when he was younger.
And yeah, me too.
Yeah, I think it helps a lot if you had those, because then you know where to go.
Have you crashed it yet? You can be honest with me.
No, I won't. No, never.
Oh, it's self-corrects.
Yeah, it's self-correct.
Am I allowed
Yeah,
up?
you will not get up the slope because the wheels will start.
I've got the wrong tyres.
Yeah, essentially.
Well, have I?
Yeah, now it will get stuck. Yeah.
You know,
About
don't
there.
you? But like you say, if we had those paddle wheels,
Yeah, yeah.
they would work. How cool is this, guys? We are driving one of the vehicles going to the moon. It's just so cool. Driving it with just a tablet. Call it a car, call it a robot, call it just a big solar panel on wheels. Whatever you think, inside of 12 months from watching this, a pair of these will be up there on the moon, driving around, trying to get high-res video of a moon buggy that was abandoned 45 years ago by the Americans. I personally think this is an awesome little feat and so much cheaper than you might think. And I've had the privilege to drive it. I love it. Jonny 5's alive.